On behalf of Partners in Project Green, I would like to welcome you to our monthly series of green technology webinars. For those of you who might not know, Partners in Project Green developed in partnership with Toronto and Region Conservation and the Greater Toronto Airports Authority is a growing community of businesses working together to green their bottom line by creating an internationally recognized eco-business zone around Toronto Pearson. We offer many resources to help companies along their journey to sustainability. For more information on our programs, training, events, and much more, visit our website at www.partnersinprojectgreen.com. We do actually have a networking session coming up on October 11th, so if you don't know about that, you can definitely check that out. So for today's webinar, we are very fortunate to have Jim Judge from EtimeEnergy calling in from Toronto, Ontario this afternoon. Jim graduated from De La Salle College in Toronto and also graduated with a marketing and retails major at Ryerson Polytechnic. For the past 22 years, Jim has been involved in the coatings industry. 7 years in the applications equipment industry, 5 years in paint systems design for industrial and automotive industries, 5 years engaged in coatings as technical rep for aviation, aerospace, and military, and the last 5 years have been engaged in nanotechnologies for coating in industrial and energy management. Currently acting as coating specialist for EtimeEnergy Incorporated, Jim is engaged in technical representation of offerings to the energy conservation sector for MASH, industrial and commercial markets. You can take it on now, Jim.
Good morning or good afternoon, everybody. It's a pleasure to be introduced by you, Alex, and thank you for this opportunity. I'd like to present our company to you folks at this point in time and describe to you. Are we good? Hang on. Sorry, folks. Okay. At this point in time, I just basically like to cover off what our company is about and how we're working in the nanotechnologies field. We're basically Canadian-based, and we're focused on providing high quality products that are functional in the technology and to reduce energy. So we've rationalized that the fenestration is the weakest link in energy preservation as far as the building envelope. And our HPS coating is our first offering, coming in designed and manufactured with our technologies to reduce the cooling and heating loads. Typically, we're seeing those loads reduced between 20 and 30%. And that offers us an opportunity now to introduce our product to you, and as a result of that 20%, we're actually reducing the value of about 8 to 10% on the total energy bill. How we're doing it is that this is a retrofit solution and goes typically for aging buildings that have windows that you are likely to replace. So it creates a thermal barrier, and this is the key to what the coating is doing. It's actually setting up a heat block that stops the transmission of heat or heat moving from either hot to cold and then coming in through the winter time, or it's moving out through the winter and it's coming in through the summer. So if it's 33 degrees outside, it's going to not be able to penetrate the heat barrier that we're providing. And it's typically about 40 to 47 degrees is what we're normally finding up in this climate here in Toronto. This reduces our cooling loads by up to 20 and 30%. And in turn, that translates to about 10% of your bill. And it'll be plus or minus, but that's atypical of what we're seeing as a result of doing the coating. Now, I will explain to you what's happening here. This is the restaurant that we have at Cora's, which I'll explain further later on. But the coated or the uncoated glass is reading at 22 degrees or 21 degrees, and our outside ambient temperature is 20 degrees. The coated glass is 34 degrees C. And the reason for this is the coating is taking advantage of the solar rays that are penetrating the window and penetrating the envelope and utilizing the infrared as well as UVA and the visible light to warm the window. And ideally, normally we see about a 10 to 14 degree difference between the two coated and uncoated areas. So what does this mean and how does it impact the inside? On the uncoated window, this meter is able to read solar transmission, and it understands it in a form of BTUs. The BTUs are basically measured by how much is penetrating into the envelope per hour and per square foot. So This is contributing 94 units on the uncoated window, which, as you saw before, is 21 degrees. On the second coated window, it's dropped to 10. Now, that's an 80 to 90% drop with respect to, or an 80 to 90% drop with respect to its ability to block what's heating the interior of the envelope. This is very significant because that's what your dollars and cents are paying for, is to keep the heat in the envelope in the winter and trying to keep the cooling in during the summer. So you see the penetration inside the building is significantly reduced. The problem, I'd like to highlight where the light that we're dealing with coming into the envelope, and it's dealing with infrared, the visible light, and the UV spectrum, and it contributes about 53% in the infrared range, and that's in the lower, longer wavelengths. And on the shorter wavelengths, you have the UV at 3%, 44% visible light. What our coating is doing is being able to isolate out the infrared rays and also the UV rays. And in the infrared spectrum, we pull anywhere between 40 and 60%, depending on the level of coating that we put on it. That's not the thickness, that's just the different types of coating. I'll explain that in a minute. The 3% of UV, we're blocking out about 90+% on that. So the ideal of what our coating is trying to do is be selective as to what components it's taking out of what's penetrating inside the envelope. And the 44%, we're trying to hold as much of that as possible. So typically we see a reduction of anywhere between 15 and 20% on the envelope with respect to the visible light. But that's atypical. Even a window will take away 8% of the visible light coming into the facility. So the problem exists both at work, where you find your offices are having a lot of glass structures that have tremendous impact of being hot during the day and not being able to close blinds, as you can see in some of these instances. In leisure, it's also affecting us. In restaurants, as you can see, the face in Jack Astor's has a lot of glass that is subject to western sun. And at the golf course, sitting in the lounge, you'll always find somewhere that you're going to be penetrating, or the heat is penetrating. And at home, sometimes you all have these solariums that you've built to enjoy the value of your home, and all of a sudden you're realizing that they are impacted drastically by the amount of light. Your plants probably love it, but sometimes it's very difficult for you to stay out there. The answers at this point in time, as they stand for most people, are the insulated glass unit is impeded by or blocking the light by putting up curtains or blinds or shutters on the outside of windows, and even people will consider replacing the windows with new upgraded low E or different types of technologies to reflect the heat coming into the building. The rolls are indicative of film that are produced by different manufacturers, and they apply them with glue, and sometimes they curl and bubble and they distort the image that you're seeing outside. So our solution was pretty simple. We wanted to work with a coating that would allow us to be spectrally selective, taking out the infrared and taking out the UV, but maintaining the maximum amount of light to come in from the visibility. And when you're looking outside, the importance of this is that you're gaining the value of what the window was designed for in the first place. Every window in the Northern Hemisphere and most offices are basically have curtains drawn on the south and west sides of the building for approximately half the day, if not more. And this is an issue because it blocks out the natural light that's been encouraged in most of the building envelopes that you'll see, either in downtown or whatever the city you're living in, or even at home. What we're trying to do here is with a very thin coating, which you'll see in the illustration. You have the solar radiation coming through at 100%, and it's being blocked by the coating. At 15% of the infrared is coming through 75% of the visible light, and ultraviolet is down to about 0.3%. And actually, it's probably maybe a little bit more in line of about 6%. What we find is this coating is 8 microns thick. And being at 8 microns thick, it's about 1 micron is the equivalent of 1/100,000th of a hair. So 8/100,000ths of a hair is how thick the coating winds up going onto the substrate. And that's what's spreading across the heat, across the window, and absorbing the heat into the window. That was creating our hotter temperature on the window face that you saw as far as the reader is concerned that we had on it. Now, what I'd like to do is just offer you the opportunity to understand we have 3 different types of coatings that have solar heat gain coefficients of 0.4, 0.5, and 0.6. These things allow more or less infrared coming into the facility and therefore blocking more of the solar heat gain. And we'll use 0.6 typically in far northern climates and 0.4 in hotter climates where we want to block more of the solar gain. So the lower the number, the higher the value is that we're dealing with. Now, as I said, it's a clear treatment. It basically it's a retrofit solution, so it solves problems on older buildings. We're doing a lot of heritage properties now in Toronto. The glasses, it works on glass as well as polycarbonates, and it lowers our temperatures about 20 degrees C, which I'll show you in the next few slides. We're reducing our loads by doing this by about 20% on heating and cooling both. And at this point in time, it also reduces the demand for more lighting, because if you're blocking the windows, you need more lights to offset the fact that you don't have natural light coming into the building. Now, I'd like to move forward on our slides and show you how the application is installed. As I said to you, this was an application that was liquid, and as a liquid, it pours onto the surface substrate of the window. This is after we've cleaned it in 3 different procedures. It's a very extensive process to make sure the window is clean. And when we pour the window, it starts from left to right typically. And what we're doing, excuse me one second, I've got to grab some water. What we're doing here is he started from left to right. So on this window, you can see the pane as to the left-hand side of the unit. You've got a much clearer point of view, and this is actually cascading down the window. The flow is cascading down. I draw you back to when you were a kid and your mother told you to go hose the windows down, and you took the hose out and then you decided to take the nozzle off. How we apply it is typical to you being a kid. Is you ran the hose across the top with the nozzle off and just putting the head to the window and watching the flow cascade down the window. We collected at the bottom with troughs that we have put in place at the bottom, and we formed them out of different types of materials in order to capture and recapture all of the materials that were flowing down the window. We reused the materials, that HPS coating that we're putting down, and so we reuse that on the next window, and typically we're seeing a usage rate of about 93 to 96% of everything that we have. So it's a very high yielding product as far as how much distance we get out of a liter. Okay, so as he's going across the window, you can see the difference on the window itself between the visibility, and that's the glare that the product also is able to lower, is the impact level of glare on the window substrate itself. So you get a better vantage point looking out, and actually the window preceding it in the bottom left-hand corner is indicative of the difference of how the coating shows. So it's a perfectly clear solution that when you're looking through it, there's no distortion. Okay, we had to check out and see that our product would be accredited by different types of laboratories and giving us value back to understand that we're within constraints of ministry guidelines and so on. So we did all the testing that we could through body coat. And actually, we went to CSA specifically, and they put us through their labs as on-spec labs. And when we checked, we did this for the value of understanding durability as well as longevity of the coating. But we wanted to make sure that it does everything that we say, that it reduces loads, it impacts the UV, it blocks those things. And in the period of time, they tested, a 15-year test was executed as accelerated testing. During this test, they ran this over 15 weeks, and during the period of time, they raised temperatures in the area. They went from high degree temperatures of maybe 40 plus and down to minus 15, 20, 30 degrees. And these are rather dramatic impacts on the testing. They throw salt water at it. They had every test under the book to try and accelerate and make this not work. We asked them to check at the point in time that they're going through that, one, it did what we said, but also check the seals on the windows to make sure that they weren't degraded by virtue of the coating and how it was acting in the environment. So they came back and they gave us a 15-year pass saying, this works, and we'll guarantee it for 15 years. And effectively, there's been no degeneration of the coating whatsoever, no peeling, no cracking. And if there was anything that was seen, it was seen as microscopic. So that's pretty dynamic as far as going through a testing procedure. We also work with labs down in the United States, Geoscience, and with the United States Department of Energy. And all these tests were conducted. So we have those available for professional people as available. Hang on for a second, folks. There we go. I'd just like to show you now a list of our customers. It's rather lengthy, so I'm just going to let you sort of peruse them by eye, and then this presentation is fully available on the website with the TRCA. So if you need to check them further, that's not a problem. Additional customers, as you can see, we've done all types of different markets in the hospitality field, banking institutions, property owners, property management teams, even Via Rail has come through with opportunities for us to work with them. And so what I'd like to draw your attention to is not just so much the list, but also some interaction with our customers. Cora's on Queensway. We had put the product in there primarily for a problem that our client, Mike McCarthy, had. And it was the fact that in his restaurant, the seating area up the very front on the left picture, it wasn't as comfortable as they wished it was. It's a southeast facing windows, and they had sun exposure right from 6 in the morning all the way through till 3 in the afternoon when they closed the breakfast restaurant that this is. And as you can see, a lot of the patrons were asking to move back into the restaurant, but it was a lot darker. Even with the light now coming through with our coating on it, it still is relatively dark. So without that, and the blinds pulled down because people's comfort level sitting by the windows being either affected by glare or by heat or by cold, determined that they didn't want to sit there. So he was losing the value of that extra seating, and it was about 32 seats that they had up in the front of the restaurant. So he was pleased to see that we put the coating on July the 1st, the first weekend in August, July 2011. And that weekend was the hottest of last summer. So what we had was an opportunity to solve his problem. And he said in his testimonial, and I'll just draw your attention to the third paragraph, since the installation on July 1st, we've been able to leave the blinds up all day and allow the light into the rest of the restaurant. Previously, clients were hesitant to sit near the windows due to the glare and the heat. And currently we're currently asked now to be seated up front. And the staff have also said that it was more comfortable to work in. That's a pretty solid statement because it's addressed the man's problem. And he was very, very pleased with this because it's saving him money. Now, here's where he's saving his money. The temperature on the door that we did not coat is 21 degrees. The temperature on the heat shield window is 34 degrees, and these were taken about 30 seconds apart in the same different parts of the restaurant. So the 34 degrees was taken at the front windows. This is the difference. The outside ambient temperature was 20 degrees, and we were able to save the money that was typically lost by the penetration of the heat load coming in. And again, that was 94 units coming in on the uncoated side versus 10 coming in on the coated side. That's dramatic. We also considered, or also did, racetrack gas, which is on a major corridor of Lakeshore in Toronto and Mississauga. This convenience store owner complained to me about the difficulty he was having, particularly with his exposure of the outside sun penetrating, and it was all day long. He had sun from start to finish all day long. As long as the sun was up, he had sun penetrating his envelope. his chocolate bars were melting. And he had to replenish stock regularly simply because the solar heat gain in the area was coming on so strongly. So I told him this would probably correct the problem that he had, and he said, well, let's try it. When we did, he was able to see out, which was a prerequisite because it's a gas station. It's very busy. He has to see his pumps. He has to know what his patrons are doing, and he wants to make sure there's no dash and go as far as gas is concerned, which the prices are driving now. His chocolate stopped melting. And that was the first comment that he had in his testimonial to me, was that he had satisfied the problems that he had been encountering with respect to it. The second thing that he said was that the air conditioning, he had 2 units operating in the facility constantly, and basically the 2 units are now restricted to 1, and it's more than enough to satisfy his cooling demand on the hottest summer in 30 years in Toronto. So he was very, very satisfied with respect to that. I really won't get into this, but you're able to see on the YouTube presentation, the address will be at the end of the presentation. You can check out his verbal testimony directly on YouTube. The difference in the temperature is about 10 degrees, as you can see, between coated and uncoated. And the temperature, or the solar impact, was on this window 122 versus 38. So, you know, it's a very dramatic difference between the two. And as you can see, it's stopped the effects and also lessened his cooling requirements. Jack Astor's is a building that we did in 2009, May, and we asked for an edited study by Man Engineering to tell us what the energy consumption analysis was. When we did this, they had a very simple statement that EtimeEnergy implemented glass coating for 3140 South Service Road in Burlington. The coating has been completed in May 2010, and the west end of the windows. This energy consumption analysis is based on the available consumption of data for this building from Burlington Hydro and Union Gas. The baseline year that was used in this was May 2009 to April 2010, and the comparison between the baseline year of the evaluation period was May 2011 to April 2012. We achieved savings in both electricity and gas. The weather adjusted, and these are weather adjusted statements, saved them 43,590 kilowatts of electricity, and that renders a 5.7% savings on the bills, and a 32 kilowatt demand savings on their peak load. And then the gas savings, they had 8,613, and that rendered an 8.4 reduction in the gas load for the consumption. So on the average, we saved about 7%. Now, if you factor in the occupancy factors and many others that happen in a restaurant, which are a little more busy than typical office buildings, you'll find that that fits within the mold of what we're talking about, of a 10% savings. Now, the next thing that we did was we allied ourselves with George Brown College, and Leo Salimi was kind enough to work with us in promoting a program for his students to engage, and there's a direct link between business and the college to work with the students and have them looking at solutions for business and industry and supporting industry. He was very skeptical off the front end of what we said, and he claiming that 20 to 40% heating reductions in cooling and loads was too great. But after he did his test, and we used a square meter box on a square footprint of 1 square meter on the roof with 4 sides that were glass, 1 meter square, and measured the interior temperature of the coated and uncoated boxes that we had created. This is the technical report that they had written, but I'll show you one of the graphs and one of the dates. And you'll notice here in the blue, the glass that was uncoated is indicated here, and he had temperatures ranging in it up to 70 degrees. With the coated side, you'll see a much more balanced, more level ability for the coating to maintain a set point temperature, and it's about 20 degrees difference. The peaks and valleys that you'll see in the top one, basically cloud cover. So the ambient temperature in this was typically around 30 degrees, above 30 degrees. So this is the effect that you had on a complete glass enclosure. The bottom line was, over the days that they tested, we saved about 2.46 on the average for the course of 24 hours. Now, Leo had indicated that this is a statement made in the third paragraph. It says, using the generally accepted industry rule of thumb, every 1 degree C in the interior temperature equating to approximately 3% decrease in energy requirements. This is logical to suggest that based on the findings of the HPS coating, that was likely to have a tangible effect on the impact of energy savings for an average customer. The peak load, which is the far right column, temperature difference, and this is between 8 and 6, you had almost a 5-degree difference, which is 15%. So between the two elements, we're well within the range of that 10% marker that we were looking at. So this is a success. They further test this summer, and in the test this summer, we set up 2 booths on two separate boxes on the roof that were both had refrigeration. The one on the left is the uncoated and coated side, and what you'll see is one is a slight bit darker than the other, and that's the tint that's contained in the coating. On the right-hand side of the picture, you'll see that there's cooling units, or refrigeration units, so that we can maintain and check to see what the energy demand would be to support the cooling load that we wanted to measure at a set point temperature, which was 42 degrees C. Here's the results. We tested on different types of fenestration. This is a double pane clear window, and you'll notice on this that you had a difference of about 11 degrees at the peak point, which is around 3:30, 4 o'clock. Typically happens around the same time of the day. And that's remarkable. It was about 53 degrees on the uncoated box, where the green is the coated with HPS heat shield. And it was 42 degrees, ranging about 11-degree difference. And in Fahrenheit, or in Fahrenheit degrees, that would be about a 20-degree difference. The interesting thing is at the bottom, you'll just see a spike that comes up in red or in blue. The blue is the uncoated box and the current being acted in order to activate the cooling. You'll see it's almost 2 to 1 in relation to the coated box acting versus the uncoated box. And that's dramatic. It's reducing your cost by almost 50% that you did not have to have the cooling load on. If you look at the next page, this is low E windows, and we wanted to find out whether or not it affected different types of fenestration that were there. And on a low E window, we were still about 11 degrees or 8 degrees difference between the two. It's about 50 to 42 degrees. So we're able then to understand more fully that the impact of this is working on all different types of windows. No matter what they are, they're going to have an effect. As far as the cooling load is concerned, you'll notice it's very dramatic. It's about 8 times the value of, or I'm sorry, it would probably be about 4 to 5 times more on the uncoated side versus the coated box. You would see that the activation of the refrigeration units kicking in. Now, the last one is the biggest surprise to me. That was the reflective bronze coating. This pushed a lot of heat away. It again fell within the 11-degree range, but the real telltale on this was the energy use. We were able to maintain a set point temperature where the uncoated box couldn't, and the cooling load had to be pushed. There was never an opportunity for our cooling load to come on. So these are all significant contributions to the value of what our coating is doing. And I'll just review where we are with this so we can move on to any questions that are there. It's a retrofit solution. It takes out and blocks 60 or 40 to 60% of the infrared. It blocks out 90% plus of the ultraviolet, and spectrally selective. It takes these particular elements out and it leaves the value of visible light coming in. The 15-year warranty is the longest in the industry, and our ROI is typically 2 to 3 years. We've seen it as short as 1, and typically I would say it's between 2 and 4 years to be on the giving side, and on larger complexes, sometimes up to 5. There's no optical distortion with this. It is a green tech product, and it saves on the landfills because you're not replacing your windows. You still have another 15 years gain out of the fact that you don't have to pull them out. This is a solution. the glare is reduced. Okay, and how you make your money back with this is it saves about 20 to 40% on your energy and cooling loads. This translates on your bills around 10%. I think we're a bit excessive on that slide, but it recaptures the views that are typically lost because of curtains and because of blinds that have to be pulled. And as a retailer of space, you're able to showcase better space. It looks better. It's cleaner. And you get premiums for it as a result. It's more productive for your staff. There's less lighting requirements, and the load on your HVAC systems have been reduced. So our install times are typically after work, and there's no inconvenience to our clients. Again, I'll direct you to the YouTube site that we have that has numerous testimonials on it from different clients, including Jeff Wolf, who owns Portland Properties, and that's a city square block of 4 stories that we coded for him, and they've had tremendous impact and results. At this point in time, I'd like to thank you. I'm going to keep my numbers up on the screen and also the YouTube and EtimeEnergy because there's a ton of information that you can get from it, and I was wondering if anybody has any questions at this point in time. Alice, I'll pass this back to you.
Yes, if there's any questions, you could type them in the chat section located to the bottom of your control panel for GoToTraining. While we get to any questions, I would like to thank you for joining us this afternoon. On behalf of Partners in Project Green and our partners, Green and Greater Toronto, Better Buildings Partnerships, and the Canada Green Building Council, Greater Toronto chapters, including our utility partners, Hydro Brampton 1, Enbridge, and a source in Toronto Hydro, we thank you again for participating in our webinar this afternoon. We do hope that you found the information valuable. So if you have any questions, you can always give me a call. And also, if you have any particular questions on the technology, you can always contact Jim as well. So I see we do have a few questions popping up.
Yep. Okay, Alex, I'm sorry, can I take this now? Or?
Yes, I'll actually state the question. So Jeff asks, where are any case studies performed on double-paned E-coated windows?
Where are the test results on double-pane E-coated windows?
Mm-hmm.
At this point in time, the testing that we did on the different fenestrations was at George Brown. The windows that we've typically been coating so far in the client base that we have been clear windows that are typically the normal windows that we look to. The exploration of working with the E-coat and reflective glass and so on was our initiative this year to see where it took us. So we've basically focused on clear glass at this point in time.
Mm-hmm. And can this technology be used in new construction?
Yes, absolutely. At this point in time, we are not working as a manufacturing facility, although we have manufacturing equipment that has been designed to work with this. We haven't worked with the window manufacturer. We've tested the coating on the inside by simply manually doing the coating and then taking it to a fabricator that assembled the window and had very good success with it. And actually some of those things will be offered up from our testing at George Brown as well.
Okay. And what is the R value of a coated window?
Well, that's the unique thing about this. There really isn't an R value tied to this, and the reason for it is that this is a different type of technology, and it's not reflecting the value of light. It's actually absorbing the value of light. So we're actually working with universities right now down in Waterloo and also at George Brown in order to effectively demonstrate for the engineering community a specific R value that can be attached to this.
Okay. And Mark is asking if they can get copies of external tests. Is that possible if you coordinate that with Mark directly by email?
Yeah, that has to happen. And also, as far as our willingness to release technical testing that we've done, it would have to be on a non-disclosure agreement.
Okay. Okay. And then have you ever had any conflicts with companies regarding window warranties?
Typically, yeah, I guess the window warranties, in every instance, a window manufacturer that sees anything different done is going to say your warranty is void. But we do address that by virtue guaranteeing the window for 15 years when we put it in. So the value of the coating is that it perpetuates the value of the window. Typically, coatings low-E coatings, many of the different types of coatings will dissipate because the seals actually break on their own between 6 and 10 years is the basic life cycle of a window without losing a gas that's between them. As soon as the gas is evaporated and the air transposes inside, the coating is made nil because essentially it oxidizes the coating itself and it stops performing. Real value of what our coating does is when it's on, it's always working. It never stops working. So your windows will always have that same performance level that the day you put it on versus the day you finish, it'll always be working for you.
Mm-hmm. Okay, so does the Ontario Power Authority approve the $800 per kilowatt for peak reductions?
At this point in time, we're working towards getting that done. I'm working also with the Ontario Energy Board for gas rebates as well. This is not applicable in their portfolio, but it is actually applicable under the custom formulation for rebates under the OPA program that's incenting. So it has to be a custom project submitted by the company itself for rebates that are available, and they will offer you a percentage of the project cost, and that probably will range somewhere in the neighborhood of about 10 to 30%.
Mm-hmm. And this is an interesting question too. Do rooms get cold in the winter? So what happens in the winter season?
Well, that's a good question because essentially the coating acts in reverse. As I said, if we hit that thermal block, the temperature outside is -15 and the interior temperature is 22 degrees ambient temperature inside. So you paid to heat that room. When the sun is on the windows, and that's when the coating is actually activated, it has to have sun on the windows. And when it is, what happens is that window warms up. So its temperature ranges somewhere in the neighborhood of about 42 to 47 degrees, regardless of winter or summer. And as a result, that 22 degrees that wants to move to the -13 outside can't penetrate the 42 degrees. It's hotter. And that's the difference between setting up a thermal barrier and acting like an insulator versus reflecting the energy away, which our competitors do, is they reflect the energy. So we're absorbing the energy to create a warmer surface area of the glass, and in turn, it blocks the transfer of heat, either inside in the summer or outside in the winter. And that's the testing that we had, and that's why we reduced the gas consumption by 8% on the Jack Astor's project that's validated.
Mm-hmm. Okay, so does EtimeEnergy apply the product or manufacture it? And do you apply to residential or ICI? And how does the product compare to other similar film products? Can this product be applied to other surfaces other than glass windows?
Yep. First of all, we can apply it to polycarbonates, is what we've tested with right now and had success with. It's not a product that can be installed by a homeowner or by an independent agent unless they've been trained. And it is a training process that we put our people through. Actually, we've developed a 60-page manual and train our technicians probably over a period of about 3.5 days that they'll go through a full training program first before we're able to apply it. I'm sorry, there's another portion of that question, Alex, and I'm not clear on what it was.
It was, does Etime apply the product or manufacture it?
We are master distributors for the product North America-wide, and effectively we install that, or we train reps and distributors in order to have the ability to install it for their clients. And the residential market really has not been bridged at this point in time. It's a very difficult market to engage, and its cost factors of doing business in multiple windows that are multifaceted with numerous panes in small areas is very difficult to be cost efficient as far as the application. Oh, by the way, folks, the cost per square foot of application is about $10 a square foot. So its yield in ROI for the buildings that we've done typically have been within that 3 to 4 year or 2 to 3 year cycle and 4 years. So hopefully that helps address your question.
And then one of the testing sheets had a security listed as an option. Is there a security benefit to this coating?
No, the coating doesn't affect the tensile strength of the window. It basically is not a security coating, so it doesn't do that.
Okay. And does the coating on the inside glass pane cause overheating between the two panes of the glass that might break the seal on a sealed unit?
That's the reason why we went to CSA and did the testing, is we validated the fact that that didn't happen. And actually in all our tests now on different types of fenestration, we're learning more and have had no degrading of the seals whatsoever.
Mm-hmm. And then also, can your coating be removed if a landlord asks for it to be done on a leased building?
Yep, absolutely. It's not a problem, and actually we use a vegetable-based stripper. It's totally environmentally friendly. You literally can stick your hand in it. Not that I'd advise it, but you can, and it's totally environmentally friendly and easy to do, and very little or no odor.
Okay. And in order to apply for incentive under Ontario Power Authority Save on Energy Program, Building Envelope Project requires energy simulation as MNV procedure. Did you have any simulation results using standard building simulation software?
Well, that was what was done through a report on jackasters, the M&V that was done and that we presented earlier in the slide presentation for jackasters. So that is done, and as I said, the results were reasonable. We would have loved to have been 12%, but basically on the average we succeeded with 7% on a building that has numerous things of flexibility. Occupancy rate throughout the course of the year varies. There's many other attributes. So on a more stable environment like an office building, we would likely have a little more ability to detail the fact. But we're generally right around that 10 mark is a reduction. And that's really incredible because we're dealing with 8 microns of a coating on a window, giving you your window back. That's what it's doing. It's holding your energy in.
Okay, so this is interesting too. Why are the doors not coated in your examples?
At this point in time, we're working on a higher level hardness on the coating to stand up to the rigors of keys smacking into it and so on. Windows will scratch no matter what you use, but typically they're not handled as readily as a door is, and that's the reason at this point that we're not coating the doors.
And how hot is the glass surface? Like, how hot have you seen it? And would it be a safety concern, perhaps, if someone were to touch it, especially toddlers or kids or even staff?
The temperature of the windows typically range around 42 to 47 degrees. Sometimes it can get a bit warmer, but it's tied to the environmental areas and climates that you're in. And even in the far south, you're probably dealing with 50 degrees. So yes, it's warm to touch, but it's not going to burn you.
And would there be any, like, I guess, any help in avoiding birds crashing into windows using this product?
Well, that's an interesting question. It's been asked many times. At this point in time, the coating is not capable of being able to act in a bird's eye as a block. So at this point in time, the answer is no, but that doesn't mean that's going to be the case for long. So. All I can say is we're trying to develop something that may help us in that area as well, which would be a very big plus for migratory birds throughout here in North America, as you can well appreciate. So, no, the answer is no at this point, but we're working on it.
Okay, so this is one of our last questions. So if anyone else has one, you could type away. Have you installed on condo buildings?
On condos. Not at this point in time, although we've been asked to get to a quote on a couple now just as our exposure is getting out there. It took us 3 years of development time just to get all the testing in place before we really got active in the marketing. And as you can see, our client list isn't really all that small, and we're doing very effective work, so we're getting out there. But the condo market at this point hasn't really been attacked, and I think mainly it's a difficult market because you have a lot of people standing over you. There's no specific time that you can get in and out when people aren't home, and as a result, they are very scrutinous and obviously take up a lot of time. So we have focused strictly on commercial, the mush market, industrial at this point in time, and that has been our focus, but not to say that it's not further changing as time moves on.
And if the increased heat is on the surface of the window, does it not add to the AC load?
No, I'm sorry, not AC load. I'm not clear what that means.
The air conditioning load? Like
no, actually, it penetrates inside the envelope of about 3 to 6 inches. So in that area, it is slightly warmer because it casts off part of the heat that's gained in the window. But because it's blocking that solar transmission further into the environment, it's taking that opportunity, and the trade-off of heating 3 to 6 inches inside the envelope versus containing the cooling load in the rest of the envelope means that the cooling stays. The testimony made by Jeff Wolf on the YouTube, again, I really direct you to taking a look at that because it'll help you understand the premise of how this has helped our different customers. So I'd advise strongly you take a look at that, but Jeff addresses that directly, that he stood back from the coated window and the uncoated window, and when he went to touch the uncoated window, first of all, it was cooler than the hotter window, or the coated window, and then when he stood back, he held his hand about 3 to 6 inches, and he said, no, it's warm here behind the uncoated window, but behind the coated window, there's still a bit of heat. But as he moved back, it completely dissipated, and actually, it was much cooler in the area behind, maybe 2 feet back from the window, that you could feel the cooling acting, whereas it was hot with respect to the solar heat gain on him behind the uncoated windows. So that's what's happening. That solar block, or that solar block that we're using the sun to create a heat block, stops that transfer.
Okay, and then when was EtimeEnergy formed? When did it
We're about 4.5 years old at this point.
Okay, great. Great, those are all the questions. The presentation and audio will be made available to you online. I will be sending out a link by end of Monday. So again, if you have any questions, you can always email me at apopeconomou@trca.on.ca, or you can get in hold of Jim Judge. Thank you again for joining us this afternoon. It was a great presentation. Thank you, Jim, and the questions were fantastic. Thank you again. Bye now.
Thank you, everyone.